Hi guys, welcome back to the channel. I hope you're all well, everyone's keeping alright. Today I've got a quick video for you, it's a short one. We're going to be remaking a fridge handle, something a bit different. But someone's come to me with this, a plastic fridge handle that's cracked. It's glued back together currently, but we're going to be making one out of stainless steel. It's going to be a quick video today, but I hope you guys enjoy it. So, straight over to the table and let's take a close look at this part we're going to be remaking. So we've got a fridge handle with two fixing points. It's pretty much just a main body and then two small brackets that come off it. It's quite simple, there's a few angles to look at and the holes obviously need to be bang on so the new handle fits straight up onto the old fridge. Material wise, we've gone for some 304 stainless steel flat. We've got some 12mm here which will offer up nicely for the main handle. You can see very similar proportions. And then for the handles off that, or the bracket should I say, we'll be going for some 6mm flat bar. But let's see how we get on and roll straight into the process. So starting off, we are going to mark the outside points of our handle and drill our centres. This is so we can create a datum and measure off these points. So we take our centres, get our measurements, and we measure that at 296. So that's from centre of the hole to centre of the hole. So now that's fixed in place, we can look to measure the main body and see what we need to cut our main bar to. Marking it up at 325. I think I cut this slightly long, but it gave me a bit of leeway in case there was leeway in case there's any error down the line. So we've chopped that on the bandsaw, slicing through that. Quick cut, nice and clean. Then back to the table to give it a quick deburr and make sure there's no sharp edges on that. Just using the old flappy wheel on the grinder. Safety specs on, of course. Right, so that's cut and in place. So we're just offering that up, checking it looks alright, which it does. Back to the jig we've created. So just making sure that's nice and square. And now we're going to look at taking some more measurements for these two brackets that will fix to the fridge. So grab the old bender, this trusty thing, had this for ages but it gets the job done, it's nothing fancy. A good bender is definitely a tool I want, but there's no cheap way into it, so this does the job for now. Flat bar straight in, lock it in place, got two dies there, and we're just literally hanging on this a little bit just to give it a slight bend. Use our template to measure up against it and check that angle, and then we're grabbing the ruler and marking some extra cut points. Definitely important here to take your time whilst doing this just to make sure you are bang on, because there's not much room for error on this part. Right, that's one done. I'm just going to check it again against the original. It's looking good. And now I was having a little think here, just offering it up, looking at whether you actually could. How are we going to mount this? Are we going to go for the same corner or a different flat? I've started now cutting my second one, so I've made a bend and I'm offering it up now and just ensuring that they match exactly, because with this really isn't going to work if our two bends are different and the fridge handle is either going to be an angle or the holes aren't going to line up. So taking our time in this bit, throwing back on the bandsaw, trimming it up, just taking our time with it, making sure it's spot on. Two handles now, or two brackets now, and we're going to look at finding a way to fixture them. So this is the hardest part of the job, I think, because you can copy it, but holding it in the right place whilst you weld it is always a pain. So taking my time with that, and now this is a quick overview of how I plan to join it. So you can see there's two ways to do it really. I can either fix the bottom edge or that inside edge there. Either would work, but I'm going for the one that needs the least modification, keep it simple. So the plan is, as I'm marking with this pen, chop this bottom corner off, and then that will sit flush with the bottom. Gives me a nice weld area, on the top and on the bottom, and there's not so much fettling around with it. Just offering it up now, just verifying that angle, what we're going to cut off. Just double checking it and then running that straight over onto my next one, so I know they're going to match exactly. Hit it with the grinder, back on the jig. You can see I've got some packers there just to get the right height. Nothing like some scrap metal to use as a packing, but it works perfectly, so I can't complain. Quick Scotch Brite. Give that metal a clean. Acetone, important, especially with stainless steel. You've got to make sure that stuff is squeaky clean before you go to weld it. Makes everyone's life so much easier. It looks better, it welds nicer. It's exactly what you want. Flick the old welder on, earth clamp on the table, and then throw the old jacket on. Try and keep my clothes in one piece rather than destroying them with weld. Sharp tungsten in, ground to a nice point, and we're going to tack away. I think I'm tacking at about 95 amps, just straight DC, just really burning it in, getting a nice solid tack with a little bit of filler, nothing too crazy. Pretty happy with that. It's all tacked, going to reclamp it and then run the rest of the welds around it, and then do my holes last thing so I can make sure it doesn't move. Back on the welder, tacking these outside edges. No filler this time, we're just fusing it. And here, dabbing away, you can hear the nice tapping noise of the filler rod hitting the weld pool, dipping in really nicely. Started a bit too late, should have gone right to the edge, but it's not too bad, we can work with that. Other side, dabbing it in. I think I cranked the current up a bit here. I think we went to about 100 amps, just because that 12mm was really sucking the heat out of it. But two nice welds, good penetration, haven't overcooked it. Now we're going to run the inside, same way, 100 amps, just dabbing it in there. Now, the worst bit of being a welder and making things that need to look really good, grinding back the welds. Grinding these flat only on the front face, just to give it that nice smooth finish, and then throwing a bit more weld in there where we're a bit low, so we're just topping it up, and then we'll get straight back on the grinder and level that off so it's nice and smooth. The body of the handle's all done. I'm at the point now where I'm going to put holes in it, so I've done the holes at the end because as much as I didn't want this to move, there probably is going to be some distortion. So being realistic with it, we'll leave the holes to the end. As we've done, I think it just gives you more chance of actually hitting the dimension you want, rather than drilling, it moving, and then not hitting your dimension. So at the start of the video, we measured these at hole centres at 296. I've got them written down. Due to slight length difference and just tolerances when making it, if I take the centres of these two bits, I'm looking at 292. So I've got 4mm to make up if I'm going from the centres. So I'm going to take 2mm outwards either side, so I'm going to add 2mm to my centre line, and then all I've got to do is work out the depth that I'm going to drill the hole. I'll probably centre punch it, drill it out, and then countersink it, and we should be happy. Then it's just on to finishing. Literally going to hit this with a nice Scotch Brite wheel, round the edges with a flat wheel, and then yeah, give it a nice brush finish, and that should be job done. So, got the old centre punch out, on the pillar drill, setting up. This old thing never stops, it's a trusty steed. Dormer drill bit, fresh out of the packet, brand new. Easing her in, doing a pilot first, so starting with a small drill bit and then working our way up. Squeals a little bit, could have done with a bit of coolant, but for two holes I wasn't too bothered. And then we got a nice countersink bit. nice and slow, load of pressure, and it gives you a really clean countersink, which is what we want, especially on stainless. Back on the Sharpie, we're going to mark our edges, literally eyeballing in, nothing too crazy, and then on the wireless, cordless grinder, running these edges in, a little bit at a time, nothing crazy, just making sure it's nice and uniform. Scotch-Brite again by hand, just to kind of deburr it, make sure there's no sharp edges, just anything we can get by hand. And then next, we're going to head on over to the machine polisher, Scotch-Brite wheel, just to really put a grain in it. You can see we're trying to keep it nice and uniform, going in the same direction, giving it a nice finish that we're looking for. So here we have it, the final part, welded up. We've left 2 welds on the rear to give it that handmade feel, but you can see it's come out nice. Not exactly the same, but from the material we're working with and the time we had, I think it's come out really well. The only thing left is check it fits, which I'm sure I'll find out straight away because it's a 2-minute job to fit this up. But there we go, before and after. From plastic, injection moulded, to a remade, remanufactured stainless steel part. Hope you guys have enjoyed the video. If you want to see more of this content or you like the voiceovers, let me know and I'll keep these sort of videos coming. Until the next one, see you then.